Hey everyone, welcome back, and today let's solve Leetcode problem 796 titled Rotate String. So we're given two strings S and goal, and we need to return true if and only if S can become goal after some number of shifts on S. So a shift on S consists of moving the leftmost character of S to the rightmost position. So for example, if the current string S is A, B, C, D, E as our input, then shifting it one shift would be B, C, D, E, A. We simply move the leftmost character A to the rightmost or the right end of the string. So we moved A from here to the end of the string, so after E, right? And that's going to mark one shift. So again, it's pretty refreshing to kind of see an easy Leetcode daily challenge problem after a lot of different mediums and hards in the previous month, October. And I think the first 2 weeks of the month or something like that, or maybe first 10 days of every month is going to have some pretty easy problems. And it's going to get progressively harder as we progress through the month. So it's only November 2nd today, so hence why we have a pretty easy problem. Okay, so in example 1, we have the input string S to be A, B, C, D, E. And our goal is C, D, E, A, B. It's just asking us, can we reach C, D, E, A, B, our goal, after shifting our string some number of times? In this case, yes, we can. If we shift it 2 times, move the A to the end, and the B to the end, we get C, D, E, A, B, which is equal to our goal, which is also C, D, E, A, B, and so we'd output true. In example 2, we have the input string S to be A, B, C, D, E, and our goal is A, B, C, E, D. So we'd output false, because no matter how many shifts we do, moving our leftmost character to the rightmost end, we're never going to actually get our input string S to match this goal, because it's simply not one possible form of rotations or shifts that we can make on our input string S to reach that value. Alright, so with that out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so honestly, this has a pretty elegant and simple solution. I wouldn't say it's the most intuitive approach. I think there's a lot more intuitive approaches that you can take. In Python, this is just going to be a one-liner. I know that's not very good for practice, but I kind of just want to show you guys how we have to really apply our problem-solving skills and our analyzing skills to really just use our logic to solve this problem really, really optimally and simply. So how do we know if goal is actually a potential rotation result after rotating or shifting our input string S X number of times? Well, it's quite simple. See, we know that the concatenation of S, so basically S added onto itself, is going to contain all the different rotations that we can potentially have after moving our leftmost character to the rightmost position. What does that actually mean? Okay, so if our goal, let me just comment this out. If our goal is a substring, or it is a possible result of S plus S, which is the concatenation of our input string S, then it means that the goal is a valid and, I would say potential rotation that we can make on our input string S. Okay, so kind of just wrote out a quick sentence here. Might not be pretty intuitive yet. So let's just kind of dive into the code here, and I'll explain it line by line. Or rather, I should say word by word, because it's only a one-liner. Right, so we can really boil down, again, this problem into 2 different cases. The first case is the length of S has to match the length of goal, right? That's pretty intuitive, I feel, because you're not actually inserting or deleting any characters. You're just moving around their positions and reordering their arrangements. So if they're not even the same length, then we're for sure know that they're not going to be a potential rotation of each other, because we can't actually insert any more characters or delete any characters to make sure they match their length to equalize these 2 strings. And so if the length of our input string S is not even equal to the length of our goal, then we can immediately return false. Now, I told you this is going to be a one-liner. Okay, let me show you guys the quick one-liner in Python. So we have to return a Boolean value or comparison of the length of S equal to the length of goal. And our second case must also be true to output true here. What is our second case? Our second case is this goal is a substring or a potential rotation or shifting result of any possible number of rotations of our input string S. And how do we get a superstring of all the different possible rotations of S? We concatenate it with itself, or we add another S onto it. So goal, or rather, and goal has to be in, or a substring of S plus S. Now this isn't simple math. I can't say 2S. That's obviously breaking the syntax of Python. I'll have to say S plus S is simply a concatenation of S with itself, meaning if goal is a substring of the concatenation of S itself, then it is a possible rotation that we can achieve after some number of shifts from our leftmost character to our current rightmost position of our input string S. And as you can see, if I were to submit this, this would be accepted and this would be a valid solution, and it is just about as efficient as you can get. So why does this work though? That's the part that I really want you guys to understand. Why does this work? Why does when we concatenate S with itself, why is that actually a superstring that's going to contain all the possible rotations of S, right? Why is that actually going to work? Let's look at example 1 again. Okay, so in example 1, let me just comment this out again. Let's just say we have, we do actually have the string S to be A, B, C, D, E. That's pretty straightforward. That's just our input. Our goal is going to be what is it? I think it's, okay, C, D, E, A, B. C, D, E, A, B. Okay, so why does this work? Why is this actually a valid approach? Let's look at it. So, when we concatenate S with itself, so we get S plus S, this is going to output to A, B, C, D, E, A, B, C, D, E. Just A, B, C, D, E 2 times, right? That's just concatenating S with itself for S plus S. A, B, C, D, E here. Oops, okay, my bad. Okay, A, B, C, D, E here. And another A, B, C, D, E right here. Pretty straightforward. Now, why does this A, B, C, D, E, A, B, C, D, E actually contain all the different rotations of S? Or rather, shifts of S. Why does that work? Okay, let's look at it. First of all, if we don't actually make any shifts on S, we simply get our original input string of A, B, C, D, E. That's nice. If our goal was already that, then we can return true immediately. But another rotation we have is if we moved A to the end of this string, or the rightmost position of the string from the leftmost position, or index. Then we get B, C, D, E, and then the A after it. That's also one possible rotation, or one possible shift result that we can have that goal could potentially be to output result, or rather true. Now, what if we had 2 rotations? Then we'd have C, D, E, A, B. That's just moving A and B to the rightmost positions. Then we get C, D, E, A, B. And that's actually, in this case, our goal. And since we actually have goal to be a substring within this superstring of all the different possible rotations of S, or shifts of S rather, we can output true. Because we see that CDEAB is a potential result after shifting the input string S, in this case, 2 times, or 2 amount of times. Now, what if our goal was something else? What if our goal was DAABC? Well, that also is a possible result. Why? Because that just marks that we're shifting our input string S 3 times. What that means is we're essentially moving the 3 leftmost characters in sequential order to the rightmost or last 3 indexes, right? So if we had A, B, C, D, E as our original input, then we'd have D, E, ABC, right? We're moving ABC from the leftmost position of our string to the right half of the string. So what if we wanted to shift it 4 times? Then we'd have AE, ABCD. We're moving ABCD, the 4 leftmost characters, to the rightmost, and we're keeping E the same. And again, our final rotation would be just ABCDE again if you moved all 5 of the characters to the rightmost part, but that really isn't changing it. That's just one full rotation. So we'd go back to our original input string, ABCDE. And if our goal is one of these potential rotation results after shifting or rotating our input string S some number of times, then it is a valid result that we can reach after rotating our input string S some number of times to actually get that result of goal. And that's actually about it. That is the entirety of this code. And this is going to have a time complexity of big O of n, where n is going to be the length of S, because again, we have to check if one string is actually a substring of another. And that's going to take linear time, right? We have to check if goal is in a substring of S plus S. And that's going to be linear time for the lookup of that string. And for the space complexity, this is also going to be big O of n, because of course we're literally duplicating our input string S just once, right? We're making a copy of it and adding it or concatenating it to itself, and so that would also be a linear time memory complexity solution. So that's going to be it for this code. Pretty straightforward here. And if you guys enjoyed this solution and learned something new, I know this isn't the most intuitive of solutions. Please feel free to like this video and subscribe to my channel. And without further ado, I will see you guys in the next video. Bye-bye.